Thank you very much for the introduction and for inviting me today, and thank you to all of you for coming. So today, as was mentioned, we'll be talking about ChatGPT. How did we get here? And what is it really able to do? How is it doing what it does? So to start off, ChatGPT, you're likely here because you've heard at least something about it. Plenty of headlines telling you a whole lot of these kind of extreme statements. We start off, we can see Hollywood screenwriters kind of signing off saying, yeah, it's okay to try to write some movie scripts using ChatGPT, at least to a certain extent. We've got OpenAI able to spread conspiracy theories, so kind of that other extreme where, wait, maybe this isn't something we should even have, this is dangerous. Got other headlines, it designs a rocket, is that going to actually make it to space? If we have the founder and we're asking him, or the CEO rather, and we're asking him, how does this work? He can pull out these quotes saying that he's scared, and he's no shortage of headlines. This is all just pulled from a quick search to say, what are some of the things that we're finding out there that people are saying about ChatGPT? Any model like this that kind of surprises some people, you're going to get some extreme responses to it. Now, it's worth noting, this isn't necessarily that surprises everyone, but you're getting the headlines from those who are especially surprised or want you to just click their article. So this last one I particularly liked, your humanity could save your writing job.
This is too late.
When you have articles like this, it really grabs your attention. You want to know what exactly is going on. What is this system? So how did we get to this point? The field of artificial intelligence, it's been around as a computing field for about 80 or so years, depending on where you pinpoint its exact starting point. But it comes down to an inspiration of humans and other animals have brains that are able to do a variety of functions. For a lot of the history of computing, we're looking to have the computer do something that a human can already do. So why don't we just build a brain and have that brain figure it out, have it learn just like the way that humans do. So we said, okay, if this is what we want to do, well, how does a brain actually work? Now again, I'll emphasize that I'm not sure if there are any with a biology background here, but don't get too upset at me while I'm going through this. This is about 80 years ago, based on what computer scientists thought biologists knew about brains. So some of this not exactly correct, but it gets us there. Okay, so that's basic level. We've got these things we refer to as neurons. Neurons pass signals to each other back and forth, and somehow that's how the brain is functioning. So let's try to build that. We've got some neurons. Let's put some connections between them. Now we can pass information. So here we're passing information from this first neuron to the other neurons. Great, that's a start. Okay, well, that's not enough. We need to continue. Maybe we add another layer of neurons. So now all of these neurons pass the information down. We can at least flow information in that way. So we're building this up, trying to make it more and more like a brain. The next step, in order to know if it's working, we need to be able to give it some input and get some output. So we're going to have an input neuron or layer if there's more than one of them. That's where we give our input. It goes through this process, feeding this information forward, and then we need some output that we can then read to say, did this actually do something useful for us? So broadly speaking, we've got this structure. Input goes in, flows through the network, whatever size that is. Output comes out, and we can check to see, was this successful? Okay, great, we're building up this structure. But if this is just a static structure, there's really no gain that we get out of this. We need it so that it can adapt, just like your brain when you fed information. Connections can be formed, connections can strengthen, can weaken. We need that ability here too. So let's give each connection a weight. We're saying there's some strength to these connections. So perhaps with what we have here, from the input, we have a stronger connection to this neuron in the middle, a weaker one down below, and somewhere in between up above. Now every connection is going to have a weight, so likewise we have all these weights coming forward. And it tells us now we have some direction to this flow. Certain neurons are going to play certain roles based on the weights that they have. Over time, we're going to try to change those weights, but general idea is we have these weights dictating where all this information is flowing. And again, this does have at least some biological basis. Synapses strengthen when they're used more. They can weaken if they're used less so that your brain can adjust its structure. Same idea here. We want to be able to strengthen these connections, increase their weight if we find them to be useful, to be productive to our task. minimize them, lessen them, weaken them, if they are either detrimental or at least not helpful to us. Okay, so how do we use this? We can demonstrate. Say our input goes in, and just as an example, let's pretend like this network was built to try to predict if it's going to rain. So we're going to say, feed it. Here we just have one input, so let's pretend this is the humidity. Feed it the humidity. It's going to do some computation, and what comes out is going to give us a number. And we'll say if that number is above, let's say 10, that means predict it's going to rain. So now we've got our input defined, humidity. It's going to flow through the network. We've got our output defined. If it's above 10, it means predict rain. So now we can use this network to see, does this successfully do what we're telling it to? So the information flows, again, left to right, following these arrows. So 0.5 goes into the input. We set that input neuron to that value. Now to flow that information forward, we look at each connection. We multiply the neuron weight by the connection weight to get that next set of neuron values. 0.5 times 2 gets us that 1, times 3 gets us the middle, times 1 gets us that bottom. Now we have what we need to flow to the next level, the next layer of this network. So we'll go one by one. Top neuron, multiply its value of 1 by each of the strengths, each of these connection weights, and we can get the values for the next layer of neurons coming from just that one. We need that from each of them, so we're going to add the weights coming from this neuron to the weights coming from this neuron to the weights coming from this neuron. So each step we're updating these weights, adding together the connections that are coming from the previous neurons. We do this layer by layer. As far or as deep as this network is, we just keep flowing that information, just multiply and add, multiply and add. And to this point, that's what the network's doing, how it's flowing that information forward. Finally, it'll get to the output. It'll do the same thing. Neuron weight times the connection weight gives you then a value. And we're going to add those together for each of these neurons. So now with this model, again, in the theoretical task of using humidity to predict whether it's going to rain, we said if our output neuron has a value above 10, we're going to say, yes, it's going to rain. So given the way we've described this model, it would predict it's going to rain. Maybe that's right, maybe that's wrong, but at least we get a prediction out of it. We can interpret these results in some way. Okay, so good, we're able to flow information forward, we're making progress here. But one thing that some of you may notice, depending on how much of a math background you have, is these are all just linear combinations of the previous layer. Linear combinations of linear combinations, you can condense these down into a single linear combination. And if you only have one input neuron, you can actually just condense this down into one connection from input to output. You don't really need all this complexity. So we go back and we say, well, what does a brain do? Why does a brain need so many neurons? Well, if you look at images of brains and how people are responding to different stimuli, different neurons fire at different times. Different neurons have certain thresholds to fire or to activate. So we're going to put that into our system as well. We're going to say, let's set some threshold. A neuron will not fire, or what we call activate, unless it reaches a certain threshold. So now here, let's set the threshold at 1. Only fire if you're above that threshold, above 1. You can see the information is still flowing left to right. In this first set, we're still going to have those values on all 3 of those. We're not going to have the input have a chance to not fire, because we want that input information to flow in. But all those intermediate connections, only follow them if you're above that threshold, if your neuron fires. Now this neuron, none of its information propagates forward because it didn't fire. This neuron, nothing propagates forward, it didn't fire. So now you have only certain paths through this network are actually firing or actually contributing. You get now something that is more powerful than just having linear combinations. And if you have many, many layers or many, many neurons in here, you get additional strength, additional power in that system. So now you actually have a gain there. Okay, well, you might have more than one input. So predicting the weather, it's not as simple as just give it one number. You have many of these. Here we're showing 3, just because that fits nicely on the slide. It could be thousands. You know, the number of inputs really varies depending on your use case, but it can scale up as much as you need. Likewise, these intermediate layers, they can scale up to the thousands. You can have say 100 different layers of this, depending on your use case. Typically not necessarily that deep, but that is theoretically possible. You can have as many as you need. It can scale up. Outputs, scale these up. So here we've got 2 outputs shown. So now maybe you're predicting if it's going to rain, predicting if it's going to snow. You can now either say when they're both above 10, that means it's going to do both, or whichever one is greater is the one we should predict, or some other threshold, whatever fits your task. And it doesn't have to be restricted to things like weather. I'm just using that as an example. So here, primarily, we're dealing with language data going in, language data coming out. So we're going to feed it in words of a sentence. Each word is going to be assigned, essentially, to some sort of number, some sort of representation, then flows that information forward. We get out some sort of, again, some number that's going to correspond to a certain word or certain words. Use that as our output information. But essentially, it's still the same process. We still have just numbers flowing through, multiplications, additions, maybe some thresholding, things like that are just manipulating these numbers the whole way through. Okay, and as I said, we will strengthen those connections. We're going to learn. So that's the next step. We need to be able to learn as we see different data. So the way that these are set up, we have, again, information flows in, information comes out. We can train these, what we call supervised learning, where we know the input, we know the desired output. So if we say 1, 3, and 2 are our inputs, and given those inputs, we know that the upper output neuron is the one that should have the higher value. We run 1, 3, 2 through the system, we see what those outputs are, and now we can judge, did it get the right output? If yes, great, let's strengthen the connections that got us there. If no, not so good, let's change up those connections, weaken the ones that led us to the wrong answer, so hopefully we can learn, we can adjust, we can get the right answer in the future. So it goes through, it adjusts these weights, feed it a whole bunch of examples where you know the input and the desired output, just keeps updating those weights, and eventually it's going to settle on weights that are able to solve a good number of the problems that you give it. Now the size of your network, the quality of your data are all factors that are going to affect how effectively it does this, but general process, it will get better over time. Okay, so now we can learn, we have these weights, that's great. How is this actually represented on the computer? Well, the important parts are neuron values and connection weights between them. If we have these values, we can group those together into a vector, so we just write them as a list of numbers, essentially, in this vector. And then the weights are going to be multiplying this vector. So we look, and we say 1, 0.5, and 2, organize those into a vector, which organizes that same information, just a different representation. All the connection weights, you've got 0.5, 0.5, and 2 are supposed to multiply the 1. So that is our first row in our matrix. You just do that for each of those weights. Now you can read each row in your matrix, gives you the weights coming out of a particular neuron. Vector matrix multiplication is going to get you the values for the next layer. So you multiply the vector of neuron values by the matrix of connection weights, you get the next layer's neuron values. Once again, now treat that as a vector, treat its connections as a matrix, multiply those together, gets you to the next one. And here, the way that the activations interact with this, I'm kind of sweeping under the rug a little bit, so there is a little bit more here. It's not there is more that you need to apply to this. You'll apply an activation function to this vector first, but the main idea is vector times matrix, maybe some operation on that vector. Vector times matrix, some operation on that vector, and eventually you get down to your outputs again. So all this boils down to just representing as vectors and matrices, multiplying them together, and doing this allows us to now store this efficiently on a computer, take advantage of a whole lot of advances that have been done on vector matrix multiplications. This is a highly optimized problem already, so now by framing it in this way, we can take advantage of those optimizations, actually train these in a realistic fashion. So even though the field of AI research is, say, 80 or so years old, the ability to do this efficiently and to train it in large enough scale to really get something that's useful is much younger than that. It's, say, 10, 20 or so years old, maybe slightly older than that, but right around that range where we have computers that are capable of handling this, we've optimized these problems enough to be able to do this. This whole process can now realistically be done on enough data to be useful to us. Okay, so I've just described essentially a feed-forward neural network. That's just one type. There are a whole lot of these out there. So we can see on this image, and I'm not going to go through and describe all of them today, because it'll take too long. We can see up on that image to your right, a whole lot of these different configurations. Most of them, you're changing up the number of neurons in different layers. You might have different activation functions in them, describing that kind of thresholding behavior. You might have to change the pattern of the connections. They all serve different functions. Some of them, biologically motivated. People said, all right, we've strayed. In the past 80 years, biology research has advanced. We know something new about the brain. Let's try to put it in there. So some people design them based on trying to get back to that idea of an artificial brain. Others look and say, there's some shortcoming just looking at our outputs. For example, generating text. For a long time, an issue was, by the time it gets to the end of a sentence, it's kind of forgotten the beginning. So let's try to build a network to learn that better, be able to better capture those dependencies. Some of them just for a specific task. I just want a classifier. I only need a couple of outputs at the end. I don't need something as general purpose. Let me customize it to my task. So that's kind of the history of how neural networks have grown, how these different architectures have come about, still based on that same premise of data goes in, vectors and matrices multiply with some other functions applied. It learns based on seeing these training examples, being able to update in that fashion. Still that same core premise, just arranged in different ways. And that brings us towards transformers are kind of one of the latest models that have been very successful at a wide range of tasks. It's just another one of these network architectures. We're trying to adjust, trying to address different issues we've had. And I will note, for those of you with really good eyesight, it says in the top of this diagram, copyright 2016. We've had several years since then, so this would be much, much bigger if you include some of those newer ones in there as well. This is just kind of giving you some sample of how this has developed over time. So transformers, very successful. It's the next step in these architectures and these designs. It's very, very well suited to language in particular. So that's what they use for GPT, and that's kind of how we got where we are in terms of the field of neural network research. Okay, so now we're finally we're talking about ChatGPT. That's why you're all here. So you have some of that now. Neural network isn't a black box, a magic black box, quite as much as it may have been before. You know, there's just numbers. We're just updating numbers. So now, what does GPT stand for? If we're looking at ChatGPT, what is that GPT? The G, generative. So we can look and say, what is a generative model? What does this tell us about the structure? Well, a generative model is one where you're trying to learn some distribution. You're saying, for example, given this sentence, how likely is it that that sequence of words would have occurred, would have been something that a human would have said? So the generative model is one that learns that probability distribution, and then from that, once it's learned it, you can sample from the distribution to create new sentences. So it's a probabilistic way of learning how to generate sentences, how to figure out words from data. In particular, this being trained on words, it has this language modeling task, as we call it. So language modeling, if you're going to train a generative language model, the idea is given the previous words as context, how do you generate the next word? So if I give you the sentence that's trained to predict the next word and I just stop there, most of you can probably figure out, I was probably going to say something like sentence or phrase or something to that extent. You get that same sentiment there. Because you all have internal language models. I can stop at a sentence, and you can probably figure out what I was going to say next. So this is trained to do that. It's something that we can do. It's something that the model is set up well to try to figure out. And so that is what this model is doing at its core, its first function. And importantly, it only needs text to learn. So what I've shown previously, we had an input and a desired output. Here the input is the sentence. The desired output is the next word. I don't need to specially formulate a data set for this. I just take any English data, hand it to the machine and say, predict the next word each time. So given trained, predict 2. Given trained 2, predict, and so on. And it's able to do this. We're able to give it a lot of low-cost data. This is really good for us because we don't have to spend a whole lot of money on these data sets. And that brings us into that next step. It's a pre-trained model. What does this mean? It means it's not the end. GPT is not where you stop. GPT is kind of where you start, in a sense. So this pre-training, they take massive amounts of data, and that's what they're going to use to do this language modeling objective. So its intended use is that it first learns English, which now we can kind of see really just learns these numbers, these probabilities. It's not necessarily showing a real understanding per se. It's learning this probability, this ability to produce what is a likely sentence. So the first step, teach it English in that sense. Next step would be teach it whatever task you want it to do. So put differently, if I want to have a conversation with you in English, first you need to know English, then we can start learning how to have a conversation. So the idea here is first teach it English, then teach it a specific task, whether that's conversation, whether that's something different like translation, whether it's any sort of thing like that. If it needs to have an English output, first teach it English, then move on to your specific task. And that's the idea with this pre-training. Teaching it English first, then allowing people to do whatever they want with that next step, with that specific task. And finally, transformer, we've already seen that's that network structure underlying it. How is everything configured? What specific architecture are we using? The transformer architecture. It has certain reasons why they chose it. So transformer, the paper that described the transformer came out in 2017. First GPT paper came out in 2018. So they immediately latched onto that model because it was showing really good benefits. In particular, in natural language processing, where we're feeding it human language, having something come out. Previously, the most popular models were recurrent neural network. You fed it one symbol at a time, and it took a little while to get through that. That would forget things, so then we gave it LSTM, long short-term memory. It could look back, but it still took a long time to get through data. Transformer kind of resolves those issues. It has the benefit of the LSTM in the respect that it can look over a long range of data and not forget things in that sense. And it has a different benefit, which is you're not having to feed it one symbol at a time. It's looking at the entire sequence and able to do everything in parallel. So for example, if I had build on successes of prior artificial neural networks, and I want to know what is the meaning of each of those words in context, I can give a different word to each one of you. And we don't have enough, it's not a one-to-one matching here, but if I handed each word to a different person, I'll put it that way, you can figure it out. You don't need to talk to each other to figure out the word in context because you have the sentence, you have the context. So this is essentially the idea behind transformer. It can figure out each word's context by looking at the sentence, and it can do that in parallel for every word. So it can distribute that work, allows it to train much faster. Okay, and for those who have some familiarity with the transformer, specifically, GPT uses the transformer decoder. If that doesn't mean much to you, the essential idea behind this is it's looking to predict the next word, generate these symbols on the output side, looking one at a time, going left to right in that output. It still has that parallelism on the input, but the output is sequential. Okay, so now, how do we actually train this? Well, we hand it a lot of English text, preferably high-quality English text, but they've kind of learned that more is better. High quality is a lesser concern, but still good. So they start off, GPT-1, handed it about 1 billion words, and said, this is English, learn it. It then tried to do this next word prediction for some span of time, some number of at least thousands, hundreds of thousands of dollars, possibly millions of dollars worth of training time. It then learned a pretty good model of English. Then they said, all right, now that that has been trained, let's use that model on whatever task I want. So I fine-tune it by handing it an input and desired output. Let's say around 10,000 of these, depending on the task. It could scale up to 100,000. It really depends how similar that task is to what it already knows, what it knows in terms of English. So GPT-1 was exposed to about 7,000 different books, unpublished books, that overall was about 1 billion words. It then learned how to model English after those books, produce sentences that looked like those. We might then give it bar exam questions and corresponding answers. We only need a small number, about 10,000 of these, in order for it to then fine-tune on this and be able to then respond to these questions. Yes?
Why was it unpublished books?
Their exact choice of data set, I'm a little bit unsure on. I know that they expressed concerns that they didn't want any overlap between their training and any test sets that they might be tested on. So that could be part of why they chose that. And
Oh,
that's
you
just
mean
for
they didn't
GPT-1.
say what the books were?
They said what the books were, yeah, but they were not part of any sort of established test set, any sort of benchmarks out there. GPT-2 and 3 have changed that, and we'll talk about those, but GPT-1, that was what they chose as their source. Books are considered high-quality English in general, so that's better than, say, taking forum data. They tried to look for something that was available, high enough quality English, spanned a variety of genres, and that's what they chose. Okay, so now fine-tune it on bar exam questions, and it did a pretty decent job at getting some responses that looked reasonable. If you want to fine-tune it on a different task, let's say you have some other, maybe not question answering, maybe you have a summarization task. So you want to hand it articles and have it come out with either a headline or some brief abstract about it. As long as you have, say, 10,000 examples of these, it can do a pretty decent job at that. And now, importantly, let's say I'm OpenAI, I've spent a whole lot of money training GPT. Well, then they just released the trained model. You don't have to retrain it yourself. You can just each download the pre-trained GPT, fine-tune it on your own data. This, much less data, much less expensive to train, you're able to now get those gains from GPT that we spent, that OpenAI has spent money training. So that's the benefit of these pre-trained models. They train once, then they can be distributed and people can fine-tune it at much lower cost, at much lower training times for their specific task. Prior to models like GPT and the others that came out around that time, the convention was, I have this task, bar exam questions. I need a large enough data set for my model to not only learn how to answer these questions, but how to express its answer in English. If I have a task like summarization, again, it needs to not only figure out how to summarize, but how to then convey that in proper English. And so I need a data set large enough for it to learn not only what the task is, but how to then convey its answer in English. Now we've separated that out. We said, learn English, as GPT does, then you just need to focus on the smaller task of creating the proper way to respond. Okay, so now that's how GPT-1 was trained. Let's move forward and see how did it get to where we are today. So GPT-1, 117 million parameters. At the time, that was considered large. Training data, 4.5 gigabytes. Again, that's around 1 billion words worth of data. And it was released in 2018.
I just want to make sure, the 117 million, that's the number of weights.
Yes, the number of connection weights are what the number of parameters are. So as it's learning, as this model is updating all of its weights, the only thing we need to store are the weights themselves. So those are the learnable parameters, learnable numbers, that 117 million, yes. Okay, so that was 2018, 1 year after the Transformer came out. They came out with this paper and showed, look, this does pretty well at a variety of tasks. All you need to do is fine-tune the model that we're releasing to you. And that was great. It was one of several that came out at the time, but it was impressive the results it was able to get. Now, a lot of researchers who were in a position like me said, I can't spend the money to train a model like GPT, but I can afford to fine-tune it. So this kind of shifted the type of research that a lot of people were doing. They said, previously I was training these larger models that were costly. Now I can train kind of smaller fine-tuning sets that are still going to do quite well. But I have to focus on that fine-tuning step because I can't afford to train GPT. And they said at OpenAI, all right, this worked well. Let's keep going. Next year, they said, large is good, bigger is better. So they went from 117 million parameters, scaled it up, factor of about 10, 1.5 billion parameters, whole lot more in this network, a whole lot more numbers that could be updated. And as a result, a lot more information that it could essentially store that it's able to produce back at higher quality. To do that, to train more parameters, you need more training data. So they said, okay, all the books that we had in that first set, we need to expand. We need to include more information. Books are good, but let's kind of vary this up. So they took things like Wikipedia. It's available, it's free, it's edited by a lot of people, so it's considered at least reasonably high quality English as well. Take a lot of the Wikipedia data, feed it in. All right, what else? Well, a lot of people use Reddit, so let's go to Reddit. But there's a lot of stuff on Reddit we don't want to include. So let's just look at posts on Reddit where it has a link and it's been upvoted a certain number of times saying users found this to be a helpful link. They followed that link, took that web page, included in their training data. The idea is they're still focusing on getting reasonably high quality data, but scaling up, again, a factor of about tenfold here, going from 4.5 up to 40 gigabytes of data. Again, for a scale, that's roughly 10 billion words at this point. So scale it up tenfold, did really well at a variety of tasks. Again, now they can show a fine-tuning on these variety of tasks. You only need a small fine-tuning set. You can get state-of-the-art performance better than anyone has done on these tasks before. So it opened up that door and said, anywhere where you're generating English as your output, GPT-2 does extremely well with only a little bit of fine-tuning. And around this time, they also said, all right, GPT-1 came out, people took note, GPT-2 comes out, people are going to use this for more than we intend. So somebody should do something about this. Somebody should, put some safeguards in place. At this point, that's about where they stopped. They just said somebody should do this. Then go a year later, scale it up again. Now they said, all right, tenfold, that was good. Let's crank it up about 100-fold on the parameters. We're up to 175 billion. This just dwarfs the models from even the previous year, even that were published around the same time. But if you look, 117 million was large when it came out. 175 billion is just absurd for when that came out. Very massive model, to the extent that they now have to train it on a cluster of different computers, not just so that it'll run in time, but because it can't fit on a single computer at this point when they're running this. So this all relies on GPUs. For those of you who have knowledge of GPUs, it has much more limited memory than general CPU. So here they have to now split this model over a cluster. There are a lot more logistics involved in trying to even set up that training. But they successfully did it, 175 billion parameters. It learned these, it did extremely well. Again, more parameters requires more data. They're now cranking that up 570 gigabytes. So we're looking at hundreds of billions of words at this point, taken from even a wider variety of sources. So they're scraping just more of the internet to try to add to their data so that they have more variety of topics in there. So if you look and you say, I'm going to ask ChatGPT some question about coding, there's a good chance it was exposed to coding on websites like Stack Overflow. So it has some reference point for that. You ask it a question like, what is in this book? Well, it's explored a decent portion of the people gathering the data for this explore a decent portion of the internet. They're able to now look and say, all right, well, this book, we have this reference source for it, so let's use that.
It's a good question.
Yes.
So in addition, the layers, the structure of layer, all those things also change. So are they sort of similar in terms of the layer architecture, or
Very
they're
similar in
different?
architecture.
Okay.
Yeah, so going GPT to GPT-2, they basically just cranked things up by a factor of 10, add more layers, that adds more parameters, but essentially the same structure. 2 to 3, more layers, so they have more parameters in that sense. They shifted a little bit in terms of what we call layer normalization. They moved where it's occurring because it was found to be better earlier on than later. So they shifted a few things around, but largely the same structure. It's still a transformer at its core, it's a transformer decoder. Yeah.
Do you know the training time?
So GPT and GPT-2, the training time was released, but I don't know it offhand. GPT-3, they said how much computing time it was, which was, I believe, in the range of like hundreds of years, but across a cluster you get that parallelization, they're able to train it much faster. So there are estimates that range from a month to several months to a year in terms of how long it took them to train it. Most of that comes down to kind of a cost. How much are you willing to spend to make it go faster? So they ran this on Microsoft Azure Cloud. They were able to parallelize it across GPUs there. They use the latest and greatest GPUs. Estimates for how much this costs to train, I've seen estimates that are around the $5 million range. So that's about how much or so they spent. But the details also get a little bit more fuzzy when you get to GPT-3. With 2, they said someone should do something about this potentially becoming a problem. With 3, they said, all right, this is too much. We can't just release this publicly, so you can't go out and just download GPT-3. You have to go to OpenAI with your input, and then they'll give you the output. They charge you to run it, but they're the ones actually running GPT-3. You can't just download this anymore. So we move from open source on GPT and GPT-2 to closed source, which they're calling a security measure here to prevent people from doing things that are malicious. They've spent millions of dollars training this. They don't want someone out there to just download it and now have $5 million resource at their disposal to do something harmful. They want to maintain at least some control over that. Furthermore, they have other restrictions in place. We'll talk about those in a little bit. But the idea is by having everything have to run through OpenAI, they have now that control over what happens with their model. They'll fine-tune it for you if you give them that supervised training data. You can pay them to do that, but they're the ones hosting it. It's closed source. They're not going to give you those actual parameter values. To a certain extent, they didn't even tell us exactly all of the training data. They said, here are some sources, here's the size, but we don't know the specifics of which pieces actually got included there. Yes?
So for computer vision, if you have the same image in your data set, it wouldn't matter if you have one of them or 10 of them, it would be the exact same thing. When it comes to language, if you have, let's say, two consecutive words, right, and then you have 3 consecutive words where the first 2 are the same in the set of 3 as the set of 2, I'm trying to understand what might be considered a duplicate in the case of data, and then how would you even try to go about removing duplicates if that was a problem, and like how could you tell that like you have 570 gigabytes of like new or kind of like
Yeah, that's a good question. So they do want reasonably high quality data here. When it was small, it was manageable. You knew these are different books. That's good, they're distinct data. As you're scraping larger portions of the web, you're going to get some duplication. And additionally, you're going to get some content you don't really want in there. So they do have a data cleaning process that's part of this whole pipeline where they get the data from a variety of sources. They're trying to clean it up. Part of that is trying to remove duplicates. It's not necessarily harmful to include duplicates per se, but it's better, saves you time if you don't. So the way that this would decide duplicates, or the way that they decide duplicates for a model like this, is given a context, you have that exact context with the exact subsequent words already in the data. So predicting the next word is coming from all previous words in its context. So let's say it has context of a paragraph. If one of those sentences in that paragraph is quoted somewhere else on the internet, it's going to be a different context, because here we had it in the paragraph, over here we just have the quote. So even though it's the exact same sentence, it's going to be considered a different context. It's not a duplicate in those regards. If, on the other hand, we have, here's a paragraph, here's the exact same paragraph, and we're not going to let it see anything around that, that's an exact duplicate. We don't need to include that. We'll throw that out. If one is shorter than the other, we may or may not throw it out depending on how much we value that shortening. Yes?
So for transformers, the process is to typically generate vectors out of words and then input it to the transformer, right?
Yep.
So do we know the embedding model that has been used by ChatGPT or perhaps GPT in general to generate their word vectors?
Yeah, so they use just the traditional embedding that Transformer does, where so each word is assigned essentially a number, which is encoded as a vector, and then use that vector to look up what is embedding for it. That embedding is then learned alongside everything else. So as it goes through, those embeddings are updated for each word in context. Here, the context being previous words in the sentence. It does not look forward. And then additionally, there's what we call position encoding in there, just like the standard transformer has. So that if I hand you different words to different ones of you, I'll also tell you where it occurs in the sentence. You can use that as additional information. But that's the same as the traditional transformer, nothing modified in GPT models. Okay, so GPT-3 is a scale up again. Move forward 2 more years, we're at GPT 3.5. This is the one that ChatGPT actually runs on. In GPT 3.5, they said not only are we not going to let you download this model, we're going to be a little bit more stingy on the details that we release. So they're a little bit less clear on exactly how many parameters. There are a lot of estimates out there saying it's at least close to this 175 billion. That's why it's just kind of a 0.5 and not a 4 at that step. Training data was larger, but we don't know to what extent. And we know when it was released, but this release is not here's the code for it. It's, again, just you can access this model through using us, through using OpenAI. Okay, so ChatGPT runs on GPT 3.5. We have that large-scale pre-training of that English data. Then we need it to learn chat. It's not just GPT, it's ChatGPT. So it needs to learn chat. Chat is that task that we need to fine-tune it on. So the process that they go through, first, train it like they pre-trained any of the other GPT models. on a large amount of data until it sufficiently knows English to a satisfactory extent. Then fine-tuning on a specific task being chat. And here, the way that they did this, they needed a sample back and forth conversation emulating what we want this model to do. So they hired people. You act as the AI bot, you act as the human interacting with it, have a conversation that we would like this system to be able to produce. They hired people to do this back and forth, and typically all of their starting points came from some data set that just picked out a prompt and said, here's how you start, now have a conversation trying to resolve this. Use that as our labeled training data, our desired inputs and outputs are now known. We can fine-tune, just like we mentioned before, on this chat task. And it makes it so that you have a chatbot that can do reasonably well with short-term conversations. The longer the conversation, the more it strays from what it's seen before, the worse it did. But you can get this chat behavior, this back and forth, going pretty well at this point. This is where a lot of prior chat models kind of stopped. They said, we know fine-tuning goes well on things like question answering, so once we fine-tuned for chat, we're good, let's release it. So notably, there have been several companies in the past, say, 5 years or so who have released chatbots and said, this is the latest and greatest, just have to take it down within a day or two and have a PR nightmare because you release something to the internet will mess it up for you. So just getting to this point, it's trained on good conversations. You give it a bad conversation, it doesn't know what to do, so it just tries to generate what is a response that may have happened on the internet to a post like this. You don't want to emulate the internet when you are a company that has millions or billions of dollars invested into technology and things like that. It just looks really bad. So they said, we can't just stop here. We have to keep going. So notably, this is something new with ChatGPT, and arguably this is the biggest change from their previous model. They've got things like InstructGPT that came before this, didn't garner as many headlines. ChatGPT grabbed a whole lot of headlines, surprised a lot of people. The main difference was incorporating reinforcement learning with human feedback. So now, after it's fine-tuned, we know humans can still mess this up, can give prompts that'll make it give bad responses, and they want to, again, mitigate that, make it look better, have better responses. So what they did was, they said the model can chat, so let's have the model chat. Give it a prompt. Here, given this prompt, it produces 4 possible responses. Then they hired a human to look at those responses and rank them in order and say, this response is better than this, is better than this, is better than this. And now notably, instead of just giving that data directly to the system, they use that to train what we call a reward model. So this reward model is trying to learn how does a human rank responses. Given enough responses, it can learn how to rank them. It doesn't have to understand them in any regard. It just has to be able to rank them like a human. So they hired people to do this, spent a long time going back and forth with data, looking at, given this prompt, what is the output? Now let me produce my ranking, train this reward model until it seemed to be doing pretty well at getting similar performance to what a human was ranking these. Now they can let it loose with that reinforcement learning part. Reinforcement learning is just given some response, you're told if this is good or bad, you then update your responses, try again, you keep going back and forth. Kind of a very popular example for this, if you think about the game Pac-Man. Pac-Man, there are very simple rules to it in terms of what's positive and what's negative. You eat one of those spheres that are there, you get a reward. That's good. That's what we're trying to do. So the reward function would say that's a good behavior. On the other hand, you collide with a ghost, you lose. That's bad. So that would be something that would be penalized. So reinforcement learning has been very successful for things like learning video games because the rules reasonably straightforward to say, this increases your score, this decreases it. Over time, the model will do more behaviors that increase its score, less that decrease its score. It's the same idea here, except now instead of feeding it to eat those little pellets in Pac-Man, we're saying, you get a reward if you picked the right response. Right being what I think a human would have picked in this regard. So given a list of possible outputs, the reward model will rank them. Given the order that ChatGPT chose, it'll then either reward it for doing the right ranking or penalize it for having an incorrect ranking. Either way, weights can be updated to now reflect this. Now, notably, this happens much more rapidly than having a human in the loop. Humans can read at human reading speed, which is severely limited compared to computers. So a computer can do this, can go back and forth thousands of times in the time it would take a human to do, let's say, one. So this is done much, much more rapidly. That's why we don't just continue with human feedback the whole way. We have this reinforcement learning, so they can update much more rapidly. Computers are, in general, cheaper than people, so people in terms of labor. So here, doing reinforcement learning is going to be much more cost-effective, much more time-effective than just having humans the whole way down. So this is the model that they use to train. They started with GPT. It's just the next iteration. They had 1, 2, 3, 3.5. They then fine-tuned, something that's been commonly done before ever since these models started coming out, ever since GPT-1. And then they notably took the next step, said reinforcement learning has been successful elsewhere, let's incorporate that as the next step on top of our fine-tuning with human feedback in the loop. And now I mentioned PR nightmares for a variety of companies when they release things to the internet, especially things trained on the internet, released to the internet. So here they've invested time into what they call this moderation API. So the idea is this is trained separately from ChatGPT. They've applied this moderation API to a variety of their products. Given a prompt, it just needs to classify, is this something that we should allow, or is this something that we should moderate and say, no, we can't respond to that? So it's just trained on a variety of these. Again, this needs labeled training data. This is a sample prompt. This is what we should say. We should reject it because of, say, one reason or another. And so they trained this model for a while on data that's separate from ChatGPT. Here they're just trying to say, given a prompt, should we allow it, yes, no? You need labeled data. You don't need to know English. You just need to know yes, no in terms of is this allowed or is this not. Okay, notably, continues to be refined. So that is part of why they're releasing it publicly in terms of use, not in terms of downloads. They're opening up, anyone can use ChatGPT because it gives them more data. So it's free to you in the respect that you're not giving them money, but they're using your data, your feedback, to inform models like the moderation API. So anything that you tell ChatGPT is fair game for them to then use as additional training data as they continue to refine this model. Now, previously, they paid people to do things like that reinforcement learning. They paid people to label these data points. Now they're just kind of harvesting a lot of that from their users. They're still paying people to do it as well, but they're harvesting from the users all that information to inform their later models. And they can update the moderation API without having to update ChatGPT. Because this is a check that happens before ChatGPT responds. So while it's millions of dollars to train the next GPT model, it's much cheaper to update the moderation API and just insert that into the conversation. And people who got early access to ChatGPT quickly were able to generate these headlines of, it gave me this really bad medical advice. It encouraged me to do something that is illegal. And as OpenAI saw these, it can mitigate its PR issues by then updating its moderation API to reject that sort of request in the future. So if you take an article from November when this first came out, and you say, okay, this is what people did to make this go wrong, let me try it now, there's a chance that it has been updated based on the moderation API and will just flat out reject that request. So this is something that they're continuing to improve, and again, this is cheaper to improve than the entire model itself. And notably, it's not just exclusive to ChatGPT. OpenAI is using this across their products. They've got a variety of products that do specific tasks, and all of those products are, or at least a good portion of those products, are using the same moderation API. So they make an improvement to what this moderation API can handle, what it can flag as bad or good, and then they'll use that across all their models. So again, kind of dividing up the way that these tasks are done makes it cheaper for them, makes it more feasible to scale this up to the future. GPT-4 came out a little over a week ago. They can still use the same moderation API on GPT-4, especially as they continue to refine that. So GPT models will continue to come out, or other models that are like them. Moderation API is reusable across those. They can just continue to improve that in parallel. Okay, so now, with that in mind, how they avoided a PR nightmare, how they grabbed some of those headlines, what actually can it do? So its use cases we can break down. They advertise a lot to businesses. Businesses are users who will pay for this service, so they advertise some things it can do for them. And notably, these work for us as well. It doesn't have to be a business, but businesses are where some of this is advertised. So things like personalized emails. Salesperson spending, let's say, 40% of their day writing and reading emails, a good portion of that could be automated by ChatGPT. So you've probably already seen things like autocomplete on your email, on your phone. This is kind of taking that to the extreme. It's given this email that you got, here is a reasonable response according to ChatGPT. Read it and edit it. And that's important. You should read it and edit it. You shouldn't just hit send. That's dangerous to just hit send, so definitely read it, edit it, make sure that it looks good, but it gives you a starting point. You don't have to write the entire email out. You say, okay, ChatGPT generated this for me, I'll just update what I need to. Customer service, we've seen automated customer service for several years. It's been getting better, hopefully, over time. ChatGPT is kind of the promise of what that future might look like. A little bit more personalized, a little less formulaic responses. It can generate more novel-looking English, and so it responds in a way that is largely considered better by most people interacting with it. To a certain extent, people may or may not be able to tell that it's a human or that it's a computer. It kind of depends on how long they're talking with it and specifically what questions they're asking. So automating customer service is a promising area to go. Again, a little bit of a danger. Personalized emails, I can read it, edit them before hitting send. Customer service, if we're going to automate this completely, we have to trust that it's going to respond in the way we want. Is that trust there? I'd say probably not right now for a lot of companies, but we're moving towards that. Brainstorming ideas, I think this is one way that this is very useful, is having a conversation with it. It has access to a whole lot of data that's out there. It'll come up with ideas that you didn't think about. So if you're a business and you have something that you want to sell, you want to come up with a sales pitch, brainstorm that sales pitch, ask ChatGPT to generate a sales pitch, it'll do it for you. Then you can modify that and say, well, I like this wording, but I don't like this wording. How can we tweak that? It can then update it. And it has this back and forth dialogue. Much easier to brainstorm in that sense, have a more personalized response than things like just Google searching for ideas. It's going to be a lot harder to find personalized results that way. Okay, here, we're in the education environment. So while some of this applies to us, what does it mean specifically for education? Well, in my opinion, this is just kind of the next step in available tools. These models have been updating over the years. It's not like ChatGPT dropped and everyone in the NLP community was like, we've never seen this before. This is the next step. It's an impressive next step, but it's the next step. How does this fit in? It doesn't replace everything that came before, but it'll update our approach. So in particular, calculators came out. Students now have access to calculators regularly. Doesn't mean we stop teaching math. We still think math is an important thing to learn. Being able to use the calculator to help you with certain math, that can be helpful. But it's still important to know math, to be able to check what the calculator is putting in and putting out, to be able to know how to do this without always having to reach for that calculator necessarily, depending on the environment. And additionally, math concepts that build on themselves. If you have future math courses, you need to know the prior ones, not just how to put them into a calculator. Likewise, translation websites, they've increased in quality over the years. When I was learning French in middle school, there were some low quality, but there were some translation websites out there that would do that translation for you. And so students were like, okay, this is great, I don't have to learn French. And they would come out with the results, and it was pretty bad. And then any of them that then took a trip to a country that spoke French, they were pretty much lost unless they had that device with them, and then they relied purely on the device's knowledge, not anything on their own. So we still value language education. It has not been entirely replaced. It is still something that's valuable. Additionally, not just for its use, but it has various benefits in terms of learning a language can then expose you to other cultures or other pieces of information you may not have seen before. So we still have benefits to learning math. We still have benefits to learning language. In my opinion, this is the same sort of idea. ChatGPT doesn't make it so that we no longer need to know anything it can do. We need to be able to then adjust to using it as a tool in the educational environment. One thing it can do very well, provide students with feedback. So in particular, when I was going through my undergrad education, I might be asked, program a merge sort in C++. I go through, I'm programming it, my code's not working, I'm trying to debug it. Now I have two main options. One, try to get in contact with the professor and see if they're willing to spend the time debugging it with me. Or two, search the internet for merge sort in C++. Very quickly you find the answer, and then it's really an ethical question on the student. Am I just copying this answer and cheating, or am I going to try to compare and learn from it But even that, it's a little bit of cheating because now you've looked at the solution when you weren't supposed to. ChatGPT, depending on the policies in the classroom, can be used to provide that debugging feedback without showing an answer. So you give ChatGPT your code and say, I'm trying to implement merge sort, can you help me debug my code? It'll then give suggestions. Not always correct suggestions, but it'll give suggestions of where you can look, where you might be making a mistake. So providing customized, personalized feedback can avoid students searching directly for answers because they can work through their questions. So perhaps encouraging students to do this, if you find that acceptable in your classroom, is one way to give them more personalized feedback, work through that debugging process. Definitely encourage them to debug on their own first, but when they get to a point where they're stuck, ChatGPT can be a good resource to help them take that next step. Creating custom practice questions. So in some of my classes, when students are preparing for an exam, for example, some of my students have an exam tomorrow, I've directed them to where they can get practice questions, and then it gives them some interactive feedback in terms of whether they got it right, whether they got it wrong. Sometimes I'll show the answer, sometimes I won't. It really depends on the context. I've tried to then have some dynamically generated questions where it'll then update the numbers so that they're not seeing exactly the same question every time. But it's still limited. If I wanted to have different wording, at this point mostly I have to put in different wording and have it then try to pick from the ones I've pre-made. ChatGPT, you ask it, I'm having trouble with this concept, could you give me some sample practice problems? It'll generate some of those, and then you can try those. And it's a much more varied, much easier way to get practice questions for learning, for studying. Notably, I think most people wouldn't have as much of an objection to sample practice questions. It's just giving the students a resource to learn more. It's not, in my opinion, it's not cheating in that sense, whereas student feedback, depending on when it's used, is kind of that area where you have to decide where that line is. And in all these ways, a supplement to office hours. I think it's not a replacement. You still need that interaction with your professor to be able to teach you, when is this actually giving you the right feedback? How do I work through that confusion with you? How do I verify that you're learning this material in the way that we're aiming? But you don't have to rely purely on this. Now students can go and say, here's what ChatGPT told me. It's not working. Why is it not working? Or ChatGPT resolved my question. Is this right? And I can just say, yeah, that's the way they should be doing this. Or I could say no, and then I'm still at the same point I was before. But hopefully, at least some of those questions can be handled by things like ChatGPT. This will keep going. Again, it's only been out since about November. This will keep going as more people use it. So if you ask, or if you go on ChatGPT, it'll present to you this kind of front page, and you go on to really make you aware. Here's what it can do. Here's what it can't do. And here are some examples. Here are some things that it can do. Here are some things that it can't do. For examples, explain quantum computing in simple terms. So it can break down these concepts for you using simpler terms. To some extent, this is just things that are already out there on the internet, but able to present them to you without you having to search around as much. To another extent, this is rephrasing some of these, and it can be helpful in that regards. And if you want then a personalized update, you say, all right, in these simple terms, I still don't understand this concept. It'll then elaborate on it. So it's nice for things like that. Capabilities, remembers what the user said. Again, we have this back and forth, and so that's a benefit. If I say I'm confused about this topic, it can update. Next time it gives an answer, it can remember I was confused about that topic and adjust its answer accordingly. Yes?
Yeah, could you elaborate on that? How does it integrate that in the model to remember earlier conversation?
Yeah, so remembering earlier what the user said earlier, this is all considered sequential data. So we're just having words go in, words come out. The way that this is achieved in this model is that the words going in stay there when the next response goes in until eventually it's reached too long a context that it can't remember. So in some of these GPT models, that context range is, let's say, 2,000 words. I think they've increased it on some others. I've seen the number 12,000 thrown out there for GPT-4. Not fully sure if that's the exact right number, but it can remember the conversation as far back as, say, 2,000 words. So it can always reference back previous in the conversation, use that to inform, as context to inform its response. So remember is really just it still has access to. It's not remember in the sense that you or I would, where we're trying to remember back, okay, I think you said this. No, it still has access to it. So it's just as if I gave it a paragraph and then said, respond to my first question. It's the same idea with the back and forth. It's just its responses are part of that paragraph in that sense. Okay, and then notably, limitations. Some of these are things that they will draw attention to, OpenAI will draw attention to. Other limitations are ones that have been discovered as it's been out there. May occasionally, and this is their work, may occasionally generate incorrect information. Now, how occasional it is, it depends kind of who you ask. OpenAI will say it's occasional and it's getting better. Users, depending on their use case, will say, yeah, but it's still an unacceptably high level. So I'll show a few examples after this of where it got things wrong. Sometimes it's easy to see it got it wrong, other times it's harder to see and it's still wrong. More notably, may occasionally produce harmful instructions or biased content. It's trained on the internet. As much as you try to filter out biased content from the internet, a lot of issues there. One, you can never filter out all of it. Two, you may not even recognize all of it. And three, as these models get larger and larger, the feasibility of filtering out as much bias as you can gets harder and harder. So Moderation API tries to limit this. There will be bias in the data based on what it saw in its training data, based on what was on the internet. Additionally, this is a probabilistic model in the sense that it's trying to, or it's a generative model, has these kind of probabilities built in. It's saying this is a probable good response, but probable good may not be what we actually want to be good because stereotypes oftentimes are put on the internet quite a lot. They become quite a lot of this training data. They will then be spewed out by the model as well. So that's something that they continue to try to improve upon, but it's definitely a work in progress and will probably never be fully complete there. And then GPT, again, pre-trained, it has to stop training at a certain point. So GPT 3.5 was trained up until data from about 2021. Nothing that happened after that point is accessible to it unless you give it some information. So you can tell it, this just happened, now given that, answer this question. And it'll do a reasonable job at that, but it doesn't know, like I tell it, my water bottle just fell off the table. It knows that, but it might not know any context of where I am or what else has happened led me to this point. Likewise, you tell it some political event that's happening in the world, it doesn't know any of the past year plus that led up, I guess 2 years or so, that led up to that point. It won't have good context to answer these questions. So there's only so much it can do in regards to recent events. That will change, that exact date will change with each model, but as long as they're using the same structure, this GPT, then fine-tuned for chat, it's going to have a cutoff point every time. Okay, so let's look at some examples. Students were learning Euclid's algorithm and how to apply it to certain cases. So we could ask it, find the GCD of 21 and 15 by applying Euclid's algorithm. And in particular, I said show your work, because if I didn't, it just gave me the answer. So if I say show your work, it then broke it down step by step, gave me a demonstration of how to do this. Now, if students are confused with my in-class explanation of Euclid's algorithm, they could ask ChatGPT the same thing. It'll then break it down, and if they don't like, let's say, step 2, they can ask, can you elaborate on step 2? And it'll attempt to do that. So again, generating things like practice problems or sample information, it does very well at that. And I said, okay, let's step this up. In my algorithms class, one question I had the students answer was something like this. Consider a variation of sequential search that scans a list of n elements to return the number of occurrences of a given string, a given search key in the list. What is the time efficiency of this algorithm in the best case? It gives what to most readers looks like a very good answer. It's going through it saying time efficiency of this variation of sequential search, so it's recognizing this is a variation of it. In the best case scenario, so again, we're picking up on that cue, is O of 1. That is a runtime efficiency, so that looks good. It then explains why this is, how we get to that case, and it's wrong. This entire response is wrong for this variation. If I want the number of occurrences, I have to search the entire string. I can't just stop at the first occurrence. So even though it said this variation, it actually just gave me a response that was just for sequential search. It made me think that it knew what I was talking about, and then presented me with the wrong answer. So this is something that it's still very prone to, especially as topics get more complex. It's going to confidently give you a wrong answer that is hard to recognize as wrong. Other times, it's a little bit easier to recognize that it's wrong. So I ask it, name colors that don't have the letter E in them. Very first one. Now this was trained on Microsoft Azure, so maybe it's biased to put that there, I don't know. But it's still the wrong answer. And then you say crimson, fuchsia, okay, maybe it just made a mistake the first time. Well then for the rest of the list, it's wrong every time. It generated 10 colors, only 2 of them didn't contain E. And again, there are some colors that do not contain the letter E. It thinks that it knew exactly what I was talking about. I read this, and if my knowledge is limited, I might just accept this as correct. Now, this one hopefully is more obviously wrong than the previous one, but the idea is, even on relatively simple requests, it'll pretend it knows, and then it'll give you something that is wrong. So its context knowledge said, this is how you should respond in terms of the sentence. This is how we can generate a list. But somewhere along the lines, it didn't quite know, in terms of its probability, in terms of these numbers going on behind the scene, that these aren't words that should come out. Still very prone to these. Fundamentally, numbers go in, numbers come out, we convert those to words, and those words aren't always going to be things that demonstrate any kind of real understanding of what's happening. And again, it is what we call confidently wrong. There's no indication here that this is not confident. It might say, I'm not really sure, but maybe this is a list. No, it says, here is the answer, I'm confident, you can hand this to your professor. That's not good. That is definitely a danger of the system in its current state. Okay, so limitations. There's a term that has been developed in the field called hallucinating. So when a neural network hallucinates, it's kind of going off, saying things that aren't really relevant to what's going on, and making up information. Sometimes this can be things like it can make up some sentences that don't really make sense in the context. Other times, it'll make up entire pieces of information. Other times, it'll quote people who didn't say the quote. Other times, it'll quote studies that didn't even happen. So this can vary in its severity, but fundamentally, it can hallucinate, and that's a common known problem in neural networks, and ChatGPT is not immune. Confidently wrong, so when it hallucinates or when it's wrong in a different way, it is still confident. We have no indication that this is something we shouldn't trust. At this point, it's very hard to tell when it's confidently right, when it's confidently wrong, and almost never is it not confident. It is a very confident model. So here, it's hard to tell. This is still a limitation. Something that, again, you shouldn't just hit send on your emails when it generates them. You should check them over. Having automated customer service, you should make sure that it seems to be doing the right thing, that it's worth replacing some humans with, if that's something you're going to do. Having this as writing articles on the internet, something that some companies are doing, just be prepared. You might have to do a retraction when your system misquotes people, when it misquotes studies that never happened. Specifically, I asked it at one point things about the way that it was trained when I was preparing this talk, because I thought, let's see what it responds with. And even about itself, it was wrong on some of these. Now, in particular, if I ever asked it about ChatGPT, that came out after 2021, that's outside of its training data. It's understandable it's wrong, but it's confidently wrong about the way itself was trained. Again, bias by training data. As more data is required, there's going to be more bias that's in that training data, harder and harder to filter it out. It's in there, that's just something to be aware of. Try to mitigate that as well. No recent world context. Again, if you ask it something that's based on recent events, it's going to really struggle. And so if you're looking at this for education, you want to design some sort of some problems that are GPT resistant in some sense. These are some things to keep in mind, how you might form those if that's your main objective. I still think that incorporating ChatGPT into the process is probably more productive. Kind of that first step might be, let's make it at least a little bit less appealing for students to just go and copy-paste, because any way that we can discourage that will then help them to learn and use it as a productive tool. And again, with these two top portions, it's known to produce bad medical advice. It's not its purpose. Do not use it for that. Furthermore, when you put your data in, OpenAI has access to that. So if you give it your medical records, that is now data that they have access to. Don't do that. It produces code with bugs or security flaws. You ask it to generate code, it gives code that looks reasonable. A lot of people will just copy, paste, hit run. That can be an issue. It can have bugs in it that cause now problems on your computer. If you have it for something that is being released, other people can use, or even just run on your own machine. Security flaws are known to be in the code that it produces. Largely, it's taking things like Stack Overflow, where it has this reference for question, code response, and it's trying to emulate that. but it doesn't have other outside knowledge of how coding is done specifically, so it's very prone to producing buggy or security flawed code. Fabricating quotations. Again, if you are now using this to generate anything that you're going to publish, that's a big deal. That's a big no-no. And as I mentioned a few times, it's considered a free research preview. So it says right when you open it, this is a free research preview. It may not be free for all time. Their other prior models are not free right now, so ChatGPT is free to use, the others are not. Perhaps they'll move towards that paid model once they've harvested enough of your responses, harvested enough of your data. And again, free here, I'm going to put free in quotation marks because, yeah, you're not paying them in terms of money, but they're going to use your interactions with it to inform their updates in the future. So this is similar to search engines being free. Most of them, there's a cost there implicit to it. Same idea here. And they get a little bit more upfront with that, saying, we love your feedback, putting this as, oh, you can make this model better. Really, we can use your information to freely update this rather than paying someone else to do it. So there's always those trade-offs there. And just like other things that have arisen in the academic context, plagiarism was a big concern when, it's always been a big concern, but with the rise of the internet, the rise of being able to access information that way and easily just copy-paste it, rather than having to put the effort into writing it by hand, there was a big concern with plagiarism. Plagiarism detection tools have risen to try to meet that challenge. Now, most learning management software out there, such as Blackboard, has at least some tools where when students upload their assignment, it can check, run it through plagiarism detection, tell you yes, no, in terms of likelihood that this is plagiarized. ChatGPT detection, it's on the rise. It came out in November. Plagiarism has been around for a while. ChatGPT hasn't yet. So detection of that, it's still young, but it's getting better. And as we get more and more of these headlines, more and more attention to this problem, this will get better and better over time. Hopefully to the point where we can confidently use it to say, this is marked as computer generated, this is marked as not, and then try to follow up. Not immediately say that means the student cheated, but try to look into, is there a pattern there among their assignments? Is there some way that we can test to see, did they actually learn this, or did they just copy-paste? And in that regard, in my opinion, it should be used to complement other things that are already in the educational system. So if we have students who appear to be just copy-pasting coding assignments, have them write at least some code in class to make sure that they have that ability, or have them debug code, or have them tell you what their code did. If they just copied and pasted, it can be hard for them to describe even their own code. So we can use this alongside these tools to discourage students from using it a bad way, perhaps encourage them to use it in a way that enhances their educational experience. And again, this is just the latest tool. It's not where it ends, it's not where it started. GPT-4 was released about a week ago. It's not going to stop there. They're going to, OpenAI and other companies will continue to produce these types of models. As more models are produced, we know how to do these. Training costs will come down. It'll become more widely distributed. So ChatGPT, it's not the end. Quality should go up. Costs should go down. Means this is not going to go away anytime soon. So just pretending like it's not there is not really the right solution either. Being afraid of it, not the right solution. Pretending it's not there, not the right solution. You need to know it's there. It'll continue to be iterated upon. And we need to now see how does that factor in, update what we need to, and increase the use of it as an educational tool, try to discourage the use of it for detracting from education. Additionally, put this note in here, there can be disagreement. This is a bit of an opinion here, but OpenAI has put considerable effort into their moderation API. Other companies, they might just be racing to produce the next product, and they might not put as much concern there. Now, whether you agree with moderation API or not, companies just racing and putting out data and models that have been trained without any sort of attempts to do something good and reduce harm, that's probably pretty much universally agreed, not really the right approach. So whether you agree with what they've done so far or not, as more companies do this, we're probably going to lose some of that, and we need to try to see what do we do when these models no longer have this moderation API? How do we handle it in that case? And that's something that we'll kind of grow into over time, try to mitigate these risks where we can. All right, so thank you for coming, for listening, and I'll open to any questions at this point.
Well, thanks very much. This was a really fascinating sort of survey. So, I'm a social scientist, and so my question might come out a little bit of sort of left field. What is the potential of a software like this to replicate historical thinking? Let me just elaborate a little bit. So in the social science, we have these endless debates between quantitative and qualitative methods, right? Where essentially, to apply statistical tools to analyze social and historical phenomena, you have to create a world that is highly simplistic, right? There's context, historical context, and geographic context you sort of wash out. And then you have people who sort of work qualitatively, sort of have this quip that, gods did all the easy problems to physicists because the context doesn't really matter.
Yeah.
And so my question, therefore, is how likely is a ChatGPT able to answer questions that are highly context specific? So, for example, if I were to ask it, what are the typical activities, professions that women work in, right? That is a question where the answer for the present will be very different than it would be for the 19th century or for Saudi Arabia.
Yeah.
Does a software like this at some point have the capacity to make these contextual differentiations to give a nuanced sort of answer?
Yes, and it mostly depends on what it has seen. So again, this is being trained on larger and larger amounts of data. Those answers are pretty likely somewhere on the internet that it may have been exposed to. So is it capable of answering nuanced questions? If prompted correctly, yes. If prompted incorrectly, it'll still attempt to answer them, perhaps incorrectly. So we saw it's prone to giving a confidently wrong response. It'll give you a confident response one way or the other. If you ask it something like, as you were saying, the breakdown of jobs in some time period, that data is on the internet. It has access, or it was trained on a large portion of Wikipedia. Likely it has some data from that time span from Wikipedia. If it can pick up on that context, it can give you a pretty good contextual answer in that sense. How well does it do specifically on those questions right now? I'm not sure. It has the capability to do it. Does it actually do it? I haven't tested it. I'm not sure. But as these models continue to improve, the idea is that they will pick up on that context better and better, be able to pick out that right information. And additionally, that same idea is incorporated into companies that are using this or trying to use this for search engines. So if you're on a search engine, you ask a question, instead of just listing web pages, it can list, here's ChatGPT's response, along with websites hopefully, but here's ChatGPT's response, and they'll want that to be more able to answer those context-dependent questions, look up that correct data. So there is definitely motivation there. It's definitely the resource because that information is online. So if it's trained on the right training data, which Wikipedia has a good amount of that, yes, it has that capability. Can it specifically do it right now? Kind of depends on your prompt.
So if it was originally trained in chat mode, a back and forth, does it ever, like if he said, what are jobs that women typically work in, is it possible it would say, when are you talking about or where are you talking about? Does it ever ask for clarifications or?
Currently, not really. Is it capable of it? Yes. Does it? No. So that's something that they're talking about with GPT-4, trying to incorporate more into the training. Currently, GPT 3.5, it's confident. It thinks it knows what it's talking about, even if it doesn't.
Yeah.
So that confidently wrong prevents it from asking a lot of those clarifying questions. They're trying to move towards that. Currently, it probably won't. It'll assume a context. So if in your prompt you ask it for, I'm doing this paper or writing this paper on 1965 England, and then you ask it the question about job breakdown, it has that context it can look at and figure it out. But if you just ask it for a job breakdown and it doesn't know the context, it'll assume one. Likely it'll assume the present, but it'll assume one regardless. So you might have to then follow up and say, okay, I want it from 1965 England. Then it can improve its answer and give that context. So picking up on context is something you kind of have to prompt it with the correct prompts. There are now positions that are out there called prompt engineers that are specifically trying to do this. So getting the information out, not always as easy as they'd like it to be, but that's kind of a developing field.
In my experience using ChatGPT, I found that it's been way more effective at taking a problem I have and coding it out versus just maybe answering a question straight up. Is there a reason why ChatGPT is, at least in my experience and a lot of other people's experience, better at solving your problems in code versus just maybe answering a question like list colors that have the letter E in them? Because like it feels like a coding problem should be much more complex for that software to handle if it's doing next word prediction. So is there some sort of difference in the way it was
Stack
trained?
Overflow.
Yeah, so there's a couple differences there. One, it's actually a much larger range of things you can say in English in terms of next word than there is in terms of valid Python code, let's say. So it's trained on things like Stack Overflow on the internet, which are generally considered to be at least reasonable code and at least syntactically valid. When it's not, someone has usually gone in and corrected it. People post things online in English, it's not always syntactically or grammatically valid, and certainly the meaning is not always something that's corrected. So when someone clarifies a post, typically they'll respond online with, here is what you should have said. But now it has both context, the incorrect statement and the correct one. Stack Overflow, more often, I feel like people will adjust an answer, edit an answer, gets rid of the wrong stuff and puts in the right. Additionally, Python has less vocabulary, has a smaller expression than English. Learning Python, in theory, is an easier problem than learning English.
Is it also doing some kind of, like, if, let's say your specific problem that you're looking for to solve with code hasn't been done in Python, but maybe it's been done in C++ or using JavaScript,
Right.
Does it do some sort of conversion or translation? Because as I understand it, some of its bread and butter is going from C++ to other coding languages. So
Yeah, so again, when you go to sites like Stack Overflow, you might see responses in a variety of languages, so it has some context of how to convert between languages in some regard. And so if you ask it for write a code to do merge sort, and it hands me C++, and I say, do that in Python, it has kind of two things it can rely on. One, did it already see that in Python? Or two, given its context of this is C++, this is Python, that occur in a similar context, I can figure out that this is how I should rewrite it. So again, it has some of that context built in based on what it's been trained on, so it's able to do that. It doesn't necessarily know this is valid Python, and it won't always produce valid Python. More often, I think the C or C++ is more likely to be invalid, but even the Python can be. But again, it's just kind of producing, I've seen this in this context, let me try to apply those same models, same methods to adapt it.
We have time for, one or two more questions. Yeah, okay.
You talk about like prompt engineers, like a new up and coming job. Is the idea that like it takes like your input and it'll kind of pre-process it in a way that ChatGPT can like best understand it, like a valid question? Like, is there any pre-processing that goes on to your prompt like right now, or are they like working towards that?
So it's a process that is referred to generally as things like in-context learning. The idea is, as I mentioned before, its ability to go back and forth in conversation is because it has access to everything that was said. It's just building up longer and longer contexts until then it runs out of space and needs to delete from that. So if you tell it, here's my context, then continue talking from there. It has access to what you said as the context. It'll use that to inform its response. So the prompt engineer, oftentimes, if we've got 2,000 words of context, they'll put, like, say, the first 100 words, give it something that should guide its responses. Next 100 words are the specific question they actually care about. So now I can look back on the way you wanted to answer to then answer that question. So in a sense, it's kind of akin to something like pre-processing, but it's more so something like what we call priming or something like that, where we're telling it, get used to this as my context, reference this when answering this other question. So the prompt engineer is getting into the right state, the right context to then answer the question in the way they want.
So Thomas Friedman wrote an article this week in the New York Times, called it was talking about GPT-4 and called it a Promethean moment, akin to the printing press, nuclear power, events that have changed the world. Do you view this as transitional or more like what Friedman talks about as transformational?
It's a good question. I think largely this is the next step, not something that's out of the blue. So I would say it's just kind of an iterative improvement on the prior results. That's part of why I structured the talk the way I did. But where it can be more transformational is that most of you likely didn't interact with GPT, didn't interact with GPT-2. So the publicity that this has gained makes it different than the prior models. So I think that's kind of the combination effect, that in terms of NLP, in terms of the field that has been researching this, it's the next step. It's an impressive next step, but it's the next step. In terms of society, it went from little exposure just within, let's say, academia and in industry to now the general public has access and are getting used to using this. So in that respect, in societal impact, it's much bigger.